Good enough is good enough. All right, Albert, what do you got?
9/8.
9/8.
9/8. Log. Base 3.
Okay.
The x equals -5 itself for x.
Cool. So like any equation we're going to solve, we have to get x by itself. So what's a good first step in doing that? Divide by what? Yeah, or multiply by it. Either divide by it or multiply by its reciprocal. So times 8/9 times 8/9. So log base 3 of x equals -40/9. So usually, I mean, if you're trying to solve a log equation like this, you typically have to isolate the log term itself. Like in this case, we had to divide by 9/8 or multiply by 8/9, those are equivalent. From here, where should we go?
We can put the x in front of the log 3.
Can't do that.
No.
So,
So you have to.
like, so here's what I think you're thinking of, is if you have something like this, like, if it was log base 3 of, like, x to the 4th, then the 4 you can bring down, but that's only if you haven't, the argument to the log right here is x. So the thing that I'm trying to take a log of is x. If that had an exponent associated with it, then we could bring that down. But we don't have that.
So is -49 your exponent?
Yes,
Okay. So then you just
it's the exponent to what base?
2, 3.
So that's basically how to kind of unwind this. So this right here is equivalent to 3 to the -40/9 is equal to x.
How does the 8/9 by 9/8 disappear?
What's 8 times 9?
72.
What's 9 times 8?
72.
That's why, basically.
Oh,
Multiplying something by its reciprocal is equivalent to dividing it by itself.
okay.
It's just when you're dealing with fractions, this is not what we're doing here, but just an example. It's mechanically, unless you're using a calculator, this is kind of tricky to deal with, which is why we usually replace it with multiplying by its reciprocal, because then we have the luxury of multiplying numerator by numerator, denominator by denominator. So instead of dividing by a fraction, we can always multiply by its reciprocal. They're equivalent operations.
On the other side of the -5, is that only to the numerator you do the 5 times?
Yes,
8?
because, so -5, I can rewrite as -5/1, and then it's the same thing. Numerator by numerator, denominator by denominator.
And how do we solve? Because that's not the answer, right?
I mean, that could be the answer.
So that would be like the exact answer?
That's the exact answer. If I wanted like a decimal approximation for it, then you would have to ask your calculator what really tiny number that is.
Okay.
But that's fine. Albert says it took that. Okay.
Can you do like the homework that we have?
Sure.
The written homework?
Yeah. Why should I do one like it when I could just do the one that's on there?
Okay, I'll give you one of them that's on. Let me give you the one that I showed you. Is that
Yeah.
the log 10.
Log base 10.
Yes. And then parentheses, x minus 4 equals to negative log 10, or minus log 10x.
Okay. And this is the thing I'm asking you to prove that you can manipulate this into x squared minus 4x minus 100 equals 0?
Yes.
Okay. So those two look like, probably deeply not obvious that those two equations come from the same place, right?
Yes.
So basically I'm asking you to do this. Take this logarithmic equation and turn it into this thing that has no logarithms at all. So at some point we're gonna have to get rid of all the logs.
So then we add log 10x.
Yeah.
The,
So this thing right here, I can't really break this thing down, that log base 10 of x. So if I want to move it, I got to move all of it. So we can add that to both sides. Algebra says I can do whatever, I can add whatever I want to both sides of the equation as long as I'm consistent. So log base 10 of x minus 4 plus log base 10 of x equals 2. So getting all of our log terms together, I think is a good move. It's easier to get rid of stuff if I don't have to, like if it only shows up in one place.
so then with the 2, are you adding it to the x and 4? Or no?
You could, I'm gonna push back and say not to do
Okay.
that. You could get everything over to one side. In fact, now that I'm thinking about it, it's probably not a big deal if we do that. If you want to move the 2 over, we can.
Or do we add the 2 logs together?
Does this have anything to do with the x2 minus 4 thing?
Yeah, we're gonna turn that into this.
Oh,
Oh,
okay,
that's the
okay.
answer?
Yeah, but so I think part A of this question is, I gave you this equation, I said to prove it becomes this.
It can be
Okay.
rewritten as that.
Yeah.
Okay.
So how did you get just 2?
It's an extension.
Added this log to both sides, so it cancels out there.
Right, so there'll be 2.
So all that's left over here is 2.
Oh, okay,
But-
okay.
But you still kept the plus log 10, so it didn't cancel out over here?
Oh, it does, on the right, it cancels out.
And but down here?
Well, then,
Oh, I get it.
well, if it's canceling out here, makes it appear on the left. You have to add it to both sides. So, I want to point out that this right here has nothing to do with logs. This is you, I mean, many times, all of you in here have suggested that I add things to one side of the equation to get rid of it. It's the same thing here, it's just the thing we're adding is this log thing that is brand new. And we're not comfortable with yet. But the thing we're doing with it is not new.
Do the logs cancel out?
They don't cancel, but you can combine those logs. Why am I allowed to combine those 2 logs?
Because
They
they're the same base.
have the same base, and they're added together, so there's a specific thing I can do with
So
it.
that would be log base 10 with the 2x to the 8, negative 8 on top. Or no?
How'd you get that?
Because you're putting 2 exponents, the x, and then does that make sense? 'Cause there's two
So for right now, let's,
No, I'm not looking at that.
okay, look, that's all to make sure.
The 2 x's?
So let's have the 2 x's.
The x in the
So
parentheses?
Yeah,
And the x that's over here by itself?
yeah.
So it'd be 2x minus 2, parentheses, x squared, x. Yeah,
I can tell you're trying to combine them, but I'm not sure how. So, I have the same base logs, and I'm adding them together. So let's do something parallel. What if it was this log base 10 of x plus log base 10 of y? How do those combine?
Log 10 x y.
Yeah, okay, so when you add the logs together with the same base, that's equivalent to putting them together and multiplying the arguments.
That's what I'm trying to do.
Yeah, so I couldn't tell if that's what you were trying to do, but yeah, so now I can multiply x
X squared.
and x minus 4, which, yeah, we can distribute, but for now, So,
Minus 4x, yeah, okay.
so now log base 10 of x squared minus 4x.
Wait, what happened to the other log 10x? You just combined
They
it?
combine because
Yeah,
that
but-
basically it's, I'm applying this.
But it doesn't become like log 20 or log 100?
No,
The number stays the same?
yeah, the bases don't alter. It's kind of like for the same reason that if I have x to the 4th times x to the 5th, what is that?
To the 9x?
X to the 9th, but you didn't do anything to the x's, right?
No, okay.
Same reason you don't do anything to these bases. The fact that the bases are the same allows you to combine them, but you don't alter the bases.
So then you distribute the x, that extra x in the.
That's what Albert had me do on that last step.
Okay.
We're a lot closer than you may realize to.
So then you do the two to the log base 10?
Okay, what do you mean by that?
Cause you still have to get the 100, and then 10 to the second power is 100.
Yeah, not a coincidence. So now here's what you have an isolated log term equals 2. I would rewrite that as something exponential now.
Okay, so then,
So here's what I would do from here.
You put that in the front of log 10 or no?
Put what in front of log 10?
X squared minus 4x?
No, you can't do that.
so is that going
So if there was like a 4 here, like an exponent of 4 on this whole thing, then I could bring that 4 down here. But it's only exponents that can be brought down.
So I mean, by looking at the answer, I know that that was just gonna come out, right? The x to the square.
So now we have a log term. Let me ask this: what's the base and what's the exponent?
So the base is 10,
Okay.
And the exponent is 2.
the exponent,
So 10 to the power of 2 equals what?
100.
Well, I mean, yes, but basically how we're like rewriting this is this. What a log term says is this. This whole thing basically says, I would like to raise 10 to something to make x squared minus 4x. That power is going to be 2.
I want to raise 10 to
So
something to make.
if I raise 10 to a power, it'll make this.
100?
So, and the,
10.
what power do I have to raise 10 to make x squared minus 4x? That power is 2. So because of that, I can say, all right, then that must mean that 10 to the 2 equals x squared minus 4x.
What's the logic? I want to raise 10 to some power to make a 2?
So let's just,
I'm trying to get the logic of the, where you're.
give me a letter to put down here.
E,
Cool, no, it's not E.
S,
That sounds good. What goes in here?
X, 2.
Actually, I changed my mind. Let's do numbers that actually like fit. Log base 2 of 64 equals what? Equals 6. So what does this mean on the left here? Well, if I want the log base 2 of 64, then what that really means is,
Is
2 to
raise 2 to
exponent
something to make
6.
it.
I want to know what power of 2
Oh, okay.
makes 64.
So 2 to the exponent 6?
2 to the power of 6 is 64.
So you want.
So it's, hopefully, so this is just true, right? There's nothing unknown in here. So hopefully, now let me try to relate that to this deeply unknown thing.
So you want to raise it.
10 to some power makes this.
To make the x.
And I'm telling you that power is 2.
Okay.
Which
X
means
to
10 to the 2 has to equal this. Because that's what a logarithm says. What power do I have to raise 2 to get 64? 6. What power do I have to raise 10 to make x squared minus 4x? 2. So if that's the base and that's the exponent, 10 to the 2 has to equal this argument. So no matter if you're looking at a base or an exponent or a logarithm, the job of the base, the exponent, and the argument are all the same. Base to the power of exponent equals argument.
Oh, that's long.
And if I spin this, basically like, all right, this is how base, exponent, and argument are related. But what if I want to change these two things around? Well, then I'm asking basically the opposite. What power do I have to raise the base to? Like, if I want to multiply a bunch of bases together to get the argument, let me be more clear. If I want to multiply a bunch of the same base together some number of times to make the argument, that number of factors of the base is called the exponent, right? That's what it means to raise something to a power, right? If I raise 9 to the power of 13, that means that I took 13 copies of the number 9 and I multiplied them all together. Like this basically says, how many copies of the number 2 do I have to multiply together if I want to get 64? 6. How many copies of 10 can I multiply together to make x squared minus 4x? 2. So 10 times 10 equals.
Is that the answer?
Pretty close. We're trying to get here, right?
Okay, yeah.
Are we seeing how that,
Yeah.
okay.
So 10 times 10 is 100.
So now we get 100 equals x squared minus 4x. And you're one step away.
And then to get rid of the 100 over here, you take
Minus
your
100.
minus
So 0 equals x squared minus 4x minus 100.
That's why it's 0. I didn't understand why it was 0.
What's that?
I did, that's why it's 0, and I get it. I didn't understand over here why it was 0.
Oh, because we just move everything on one side of the
Yeah.
equation. Yes.
Would the x squared minus, sorry, 4x still remain in parentheses?
Doesn't really need to. Because now that we get from here to here, what am I doing with the x squared minus 4x? Like there's nothing that's happening collectively to it. The parentheses is here because I need to emphasize that I'm taking the log of all that. So the parentheses is crucial here. But here, like, me writing the parentheses or deleting it, like, doesn't do anything material to that. That's why I didn't write it. What else?
Can we do the other one?
Huh?
Can we do the other problem?
The other parts of this?
Oh, no.
Okay, good, because I believe strongly this is the hardest thing I asked you to do on this. I couldn't, your experience may vary, but I think this was,
Yeah, I feel like when I see them, I just go blank.
anything else about this before I strike it?
Okay.
It'll be on YouTube tonight. Okay, what was the other one, Jessica?
It's 4 times 5 in parentheses to the power of 2x minus 1, and then minus 8,
Like that?
yeah, equals 40.
Cool. Oh, that's a good one.
Yeah.
4.5 or 45?
4 times 5.
Oh, 4 times.
It's meant to be a inline dot,
Okay.
not floor level.
To the 2x minus 1?
Mm-hmm.
I'm curious,
I'm
your
gonna-
dry erase markers going together. That's minus 8?
Yeah,
Minus 8.
that's a good place.
That guy came and snuck in there.
How about you,
knocked
dark
those
blue?
caps off your neck.
Okay, we're going dark blue.
Thank you.
Don't you have to like log both sides to be able to move
Sorry,
the
Trash.
exponent out?
Why, for some reason I guess the janitor on top side does his balance.
We're gonna have to do a log at some point. I think right now it's not the right time. So I know I keep saying it, but I think it's a good place to kind of guide us, like where to go, like where to start. We want to isolate X. So because of that, we need to be careful about how we get there. So I know I've written PEMDAS a bunch of times, but mostly what we are doing when we're solving equations is undoing. Basically, when we solve an equation, we're not trying to do a string of calculations, we're trying to undo a bunch of calculations or a bunch of operations that led to that.
Kind of work backwards.
So now we have to basically let's start with addition and subtraction. Is there any addition and subtraction that has to be dealt with?
-8.
There's a -8 that I gotta move, so how do I move it?
Aye.
Add 8, so +8 to both sides gives me 4 times 5 to the 2x minus 1 equals 48. Now so we did, I don't think there's any more subtraction or addition to deal with. There is multiplication that has to be undone. So 5 to the 2x minus 1 equals 12.
Wait, isn't that 4 times 5, so you wouldn't multiply that first to be 20
No, because
because of the PEMDAS?
of PEMDAS.
Okay,
5 is raised to this exponent, right? So I'm not allowed to multiply these bases until basically you multiplying the 4 by 5 here is effectively ignoring that exponent. You're letting multiplication take priority over exponents, which is why we can.
So is this changing the log to move the 2x?
Now you have to do a log. What base replaces the log of?
Natural?
Sure. Natural log of this equals natural log of 12. So the natural log of 5 to the 2x minus 1 equals natural log of 12.
how do I know when it's a natural log or a regular log?
The good news here is it really doesn't matter. Because why do you want to use a log here?
Because you have to bring the 2x and the one in front.
The thing I want to solve for is in the exponent.
So you have to move, that's what you say you have to.
Any log will allow me to move that.
Wait, say that again, what
So-
I'm trying to solve for is the exponent?
Yeah, so the exponent, the variable that we're trying to solve for is in the
Yeah.
exponent, right?
Okay.
It's really hard to get at those. Unless we're able to bring that down in front.
Okay,
We're only allowed to do that when we're dealing with,
when you do
A
the
log.
logs, okay.
we could have done log base 5, that would have gotten rid of the base like all at once. I don't think but we could, in natural log, if I thought it was a bad idea, I would have suggested something else. I think this is a good place to go.
So you can still divide it though, right?
Divide out.
If you, once you move, so don't you have to move 2x minus 1 in front of the natural log?
Now I got 2x minus 1 times natural log of 5 equals natural log of 12.